Welcome to the Automation World Get Your Questions Answered podcast, where we connect with industry experts to get the answers you need about industrial automation technologies. And you can find even more answers by subscribing to Automation World magazine at subscribeaw.com. That's subscribeaw.com. I'm David Greenfield, Director of Content for Automation World, and the reader question we'll be answering in this episode is, how do soft starters and variable frequency drives compare? And joining me to answer this question is Jacob Becker, System Solution Architect at System Integrator TriTech Automation. So thanks for joining me today, Jacob.
Thanks for having me, David.
So, Jacob, I've often heard that the decision to use a low voltage soft starter or a variable frequency drive depends, of course, on the application. But before we get into that discussion, I'd like to take just a moment to look at the two technologies themselves to make sure that all of our listeners are on the same page. So let's start with soft starters. What are they essentially and what do they do?
Sure. So a soft starter is simply a motor control device that allows, as the name would imply, an electric motor to be started up slowly or softly. It uses SCRs, which are basically solid state relays back to back, and it reduces the voltage to the motor, and thus it reduces the current to the motor, which will allow the motor to start up slowly and in a controlled fashion. The time that this slowness of start takes place is configurable, as is the reduction in the voltage. So this allows the motor to start up slowly and gently and reduce stress on some mechanical pieces.
Now let's do the same for VFDs. I think most people are aware that, their main use is to control motor speeds, but can you describe in a bit more detail what they are and what they're used for?
Sure. So a variable frequency drive is a bit more of a complex motor control device. So like the soft starter, it does start and stop motors. But as you mentioned, the VFD allows the motor to be controlled, its speed to be controlled continuously. So a VFD actually takes the incoming AC power, rectifies it to a DC voltage, then uses IGBTs to take that DC voltage and invert it into a square wave waveform that simulates an alternating current. With that simulated waveform, we can modify the frequency of the waveform and thus change the speed of the motor.
And just before moving on, and then we can talk about this later too, but you mentioned IGBTs. Can you give just a quick explanation about what those are?
Sure. IGBTs they're transistors. So they're switches that fire very quickly, and that's what allows us to get that waveform. By turning them off and on very quickly, we can generate a square wave.
Thanks for clarifying that. So there seems to be, three big differences when you look at comparing soft starters and VFDs. The first of which, of course, is cost, with soft starters being the cheaper option. Then there's the ability to control motor speed, which VFDs offer, but soft starters lack. And then there's performance parameters and tuning capabilities, both of which have more options on VFDs than soft starters. But beyond those main factors, are there other key differences that users should be aware of when deciding between the two?
Sure, absolutely. The first would be complexity. A VFD is a considerably more complex piece of equipment than what a soft starter is. It has a lot more active components, IGBTs, capacitors, rectifiers, things of that nature. Since it has more active components, like you mentioned, there is additional cost. There also is a size difference. For a like-for-like motor size, a VFD is typically going to be fairly bigger than a soft starter. We all know that plant floor space is at a premium, so if you don't need a VFD, a soft starter might be a great way to save some space and additionally some cost. The next difference is heat. Like I mentioned, there's a lot more active components in a VFD. A VFD of equal size to a soft starter will put out considerably more heat than a soft starter will, because the components, as we'll talk about later, are always active on a VFD. So a lot of the components that we need to worry about are around the installation of VFDs, so the size, the heat. Additionally is cabling. So with a VFD, since we chop up that waveform and we create that simulated square wave out on the line, you can get a reflected wave back on the cabling. So oftentimes a special cabling and then a line reactor is also recommended for long runs to prevent harmonics from being passed back onto the power source. So if you have a lot of VFDs with long runs, you run the risk of getting harmonic distortion on your power source, and that can affect other equipment in the plant, especially sensitive equipment like instrumentation or PLCs.
And I imagine would that also have an impact on the type of enclosure that you choose based on that as well?
It absolutely would. It's going to make your enclosure a lot bigger, and that's going to come back to space. And yeah, VFDs take up quite a bit more space.
So, with more manufacturers, looking to make their operations, more sustainable and reduce energy costs, I would think that overall efficiency would be an important consideration when making the decision between a soft starter or a VFD. I mean, on the one hand, you have the ability with a VFD to control motor speeds, which can have a significant impact on efficiencies and cost. But soft starters also help reduce motor energy use. And looking at the overall operation of the two devices, soft starters often edge out VFDs in terms of operating efficiency, though just by a couple of percentage points. So, considering all these issues, which one is likely to be the more efficient energy choice overall?
Sure, that's a great question, and like a lot of questions in engineering, it's kind of it depends. It all comes down to an application standpoint. If you have a motor that you know you're going to start up and you want to start it up in a controlled fashion, but it is going to run at a fixed speed all the time, the soft start is the clear answer. Simply due to the fact that a lot of soft starters have bypass contactors either inside them or they will be added externally. So that means once the motor is up to speed, we will energize the bypass contactor, and then the soft starter components will actually shut down and not use any power. So there's no efficiency loss there. The only time they're active is during the startup and potentially, depending on application, the shutdown of that motor. Now, a VFD would be more efficient in an instance where you might be able to start up a motor and run it at full speed for a period of time. But during a low load application, you still need to run it, but you can reduce the speed of that motor, say for a fan or a pump during a low load application, but you still need those devices to run. You could slow them down, and that would be a more energy efficient standpoint. But if you need to start it up and run it at full speed at 60 hertz all the time, the VFD will be constantly active. The IGBTs, the filters, everything is active, and that draws some power and will make them slightly less efficient. Though both devices are extremely efficient as far as equipment goes.
So it gets back as just those couple of percentage points difference really between them in efficiency. So it really, again, as we alluded to earlier in the discussion, that it really depends on the application. What you're doing with the motor is the biggest factor in terms of that when it comes to efficiency anyway.
Absolutely.
So comparing the two technologies side by side, how do they stack up in your opinion? And by that, I mean, what types of applications would a soft starter make more sense for? And for what kinds of applications would a VFD make more sense for?
Sure. So as I alluded to in the previous question, the soft starter really makes the most sense whenever you have kind of a constant load and a constant speed application that still needs a gentle start or a gentle stop. This might be a fan or a pump, could be conveyor belts. Soft starters are great for conveyor belts where if you need to start a belt, but you don't want things on the belt to fall over, soft start would be a great thing. You could slowly ramp that motor up and then run it at full speed and then slowly ramp it back down. I've seen a lot of soft starts on screw compressors for refrigeration to keep from banging the screws on, slowly ramps the screws up. Same thing for pumps. You could use a soft start for a pump that is going to run at full speed all the time, but you want to mitigate water hammer, for example. Now, VFDs, on the other hand, are almost infinitely flexible. Flexible, tunable, they offer more precise control. Like I said, they're a much more complex piece of equipment than a soft start. So, in my opinion, VFDs kind of eke out soft starts on almost all applications up until you get to a certain motor size. There's kind of a break point where it just makes more sense to put a VFD in. So any kind of a pumping application where you want to modulate flow, but you don't want to put a control valve in, for example, that's a great spot for a VFD. We do that all the time. You may want to put a fan in and modulate the fan speed for cooling, but you don't want to add a damper to reduce your flow rates at certain times. A VFD is a great application there. Also on smaller conveyor belts where you need to modulate the speed on, say, a packaging line so you can handle accumulation or equipment shutdowns. You may want to slow those down. But really, most of the time, VFDs can work just about anywhere a soft starter would work. They're just a little bit more expensive once you get to, well, they can be quite a bit more expensive actually when you get to a larger size motor. But for like a 50 horsepower motor and below, we typically recommend our customers just go with a VFD instead of a soft starter. That way they have that flexibility should they want it just kind of built in, and it's already there for them to use.
And I guess the cost difference that you referenced there, and that pays back for itself over a certain amount of time, depending on usage, to make it worth that initial upfront cost.
Generally speaking, yes. And like I mentioned before, a lot of the considerations that you have to take into account, such as the cabling, the filtering, the heat, the enclosure size, on smaller motors, like I said, 50 horsepower or less, that's not quite as big of a deal. The cost isn't quite as drastic there. The cost differential between soft start, both the equipment purchase and the installation cost gets wider. That gap gets wider as the motors get bigger. But for a lot of customers, or a lot of our end users, the VFD brings a lot more flexibility that they may not have with a soft starter. And that's the ultimate difference, in my opinion, between VFDs and soft starters, is the flexibility that you get just out of the box with a VFD.
With all the parameter options and everything else that come with it, besides starting it running off or on, basically.
Yeah, exactly. That's the case with a soft starter. It's off or on. You can do reversing with them. It's a little bit more complex than doing reversing with a VFD. A VFD is basically just, you'd say, run in reverse, and it runs the motor the other direction. For the soft starter, a lot of times you have to have reversing contactors, which adds cabling cost, installation cost, more maintenance.
All right. Well, Jacob, thank you for all of these insights in this discussion. But, I know we've just really, hit this topic at a very high level. I mean, there's a lot more granularity that you can get into with both of these technologies. But before we sign off, are there any other points that you'd like to add about choosing between a soft starter and a VFD that we haven't covered here today that our listeners should be aware of?
So we haven't touched on across the line starters, which are another means of motor control. An across the line starter simply takes line voltage, let's say 480 volts, closes a contactor, and sends full 480 volts to our motor. So that starts the motor up, gives it full inrush current, it gives it maximum torque, everything that the motor wants, and starts it up as quick as possible. For some applications, this is perfectly fine. For others, where you may want, like I said, for soft starters, where you may want things to start up easily, you may want it to start up gently to protect equipment, to reduce current inrush. That may not be the best application, and that's where a soft starter would work best. Or if you need to control the speed, that's where a VFD would step in.
Well, thank you again for joining me for this podcast, Jacob. And thanks, of course, to all of our listeners. Please keep watching this space for more installments of Automation World Get Your Questions Answered. And remember, you can find us online at automationworld.com and subscribe to our print magazine at subscribeaw.com to stay on top of the latest industrial automation technology insights, trends, and news.